Hello everyone, this is Revati M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we are discussing about the theoretical fundamentals of artificial intelligence. First, we see what is artificial intelligence. So it is a branch of computer science that focuses on creating systems capable of performing tasks that normally requires human intelligence. These tasks include learning, reasoning, problem solving, decision making, and understanding languages. So the learning objectives of this unit are to understand the AI concepts, learn the Turing test, then explore the primary goal of AI. We will also understand how AI combines knowledge from different disciplines. So, and how it is applied in real world applications. So AI not just a technology, it is a multidisciplinary field that aims to make machine thinks and acts intelligently. So the formal equation of artificial intelligence, AI can explain using a simple formula, that is intelligence equal to perceive plus analyze plus react. So first the machine perceives information from its environment using sensors, cameras, microphones and data inputs. Next one is analyze the collected information to understand the pattern and make decisions. Finally, it reacts by taking appropriate actions based on its facial features and this identify a person like that. Similarly, self-driving car perceive road condition, analyze traffic situation and react by steering or braking. So this perception analysis action cycle forms the foundation of AI system. Next, we see the engineering AI to the design thinking lens. So here we are in AI, we are structured problem solving approach known as design thinking. So the process begins with the empathy, then we were understand the needs and challenge of user. Next, we define the problem clearly. Then we generate ideas and possible solutions during the ideation stage. After that, prototypes are developed and tested to evaluate the effectiveness. Finally, feedback is collected to improve the solution. In AI projects, design thinking ensure the technology is developed to solve real human problem rather than simply. Next, we see the Turing test. So it was proposed by Alan Turing in 1950s to determine whether machine can exhibit intelligent behavior similar to a human. In this test, an integrator communicates separately with a human and a machine. So here the integrator placed, then he is communicate with the human and machine. If the integrator cannot reliably distinguish the machine from the human, the machine is considered intelligent. Although modern AI system can perform impressive tasks, so the Turing test remains an important milestone in AI history because it introduced the idea of evaluating machine intelligence to behavior rather than the internal mechanisms. Next, we see the two major objectives. One is a scientific goal, another one is a engineering goals. Here, scientific goals focus on understanding how human intelligence works, including learning, reasoning, and decision-making process. Researchers study the human brain and cognitive behavior to gain insights into the intelligence. So next one is the engineering goal. It focuses on building the intelligent system that can solve practical real-world problem efficiently. Example include autonomous vehicle, so recommendation system and virtual assistance. So while scientific AI seeks knowledge about intelligence itself, engineering AI aims to create useful application to improve people's lives. Next one is a interdisciplinary foundation for artificial intelligence. So here philosophy contributes concepts of reasoning and logic. Mathematics provides probability, statistics and optimization techniques. Computer science supplies algorithm and programming methods. Next one is a psychology. It helps the human understand human learning and cognition, inspires neural network models. Next one is biology, neuroscience, then evolution. So AI can create system capable of learning, reasoning, and interacting with human effectively. So that interdisciplinary nature is one of the reason AI is so powerful and versatile. Next one is the techniques and subfields of the AI. So here we are using the machine learning. So here it's learned from the data. Then natural language process. It is used for understand the human language. Next one is the computational vision. It is to interpret the images and videos in the data data. So next one is this speech and planning. Here speech synthesis, goal-oriented decision makings are taken. Next one is the expert system. Here it is used to make the decision making. Next one is robotics. Here the intelligent physical agents will use. So these are the techniques and subfields we are using in the artificial intelligence. So next one is a behavior cycle. First one is a perception, understanding, and action. Here knowledge representation must ensure accuracy, completeness, efficiency, ease of reasoning, and real world applicability. Next one is a physical symbol system hypothesis. So here that intelligent behavior can be achieved through the manipulation of symbols and symbolic structure. According to this theory, intelligence involves representing knowledge as symbol, processing those symbols using rules, and producing meaningful outputs. Next one is the autonomous vehicle term. Here, the vehicle uses cameras, radars, sensors to perceive its surroundings. Computer vision identify roads, vehicles, and traffic signs. Machine learning algorithm analyze the information and predict possible situation. The planning system determine the safest path, and control system perform actions such as perception, understanding, and action combined to create an intelligent system capable of operating with minimal human intervention. So here the mind map. So it in a here we seen about the evolution of Turing test and concepts of AI and goals of scientific and engineering. Then real world applications. So we come to the end of this section. I hope you enjoyed this session. Thank you.